Morning student, I am Vijay, aithekar, Department of Applied Physics, Faculty of Education and Methodology. Today I am giving my video lecture on subject modeling and simulation discipline B.Tech and B.Tech FBT 9 trimester and B.Sc FBT 9 trimester. Topic name is process and derivation of heat transfer theory. Uh, as we know that what is heat? Heat is the form of energy. It can be converted from one form to another form. It is by three processes: convection, conduction, and radiation. Application of heat. As previous chapter, we know that heat is the form of energy. It can be converted by three methods: radiation, and uh, condension. Application of heat transfer. There are many applications nowadays. Of there are different fields. For example, first in mechanical engineering, heat transfer used in boiler, heat exchanger, turbine system, internal combustion engines, etc. In metallurgical engineering, furnace, heat transfer of components, etc. In electrical engineering, cooling system for electric motor, generator, and transformer, etc. Another heat transfer theory application is in chemical engineering. It is used for process equipments used in refineries, chemical plants, etc. Nuclear engineering in removal of heat generated by nuclear fusion using liquid metal coolants, design of nuclear fields rod against possible burns out, etc. In aerospace engineering and space technology, in designing of aircraft system and the component of rocket, missile, etc. Introduction. Heat is the form of energy which can be passes from one body to another body. Temperature of body to at lower temperature. Heat defined in the physics as the temperature of thermal energy across the well defined boundary around the dynamic system. The unit of it is in joule. The flow of it is all preserved. The overall driving force for the heat transfer is the temperature difference. Heat cannot be measured directly by an instrument as the temperature is by thermometer. The exchange of kinetic energy of particles through the boundary between two systems which are the different temperature from one to another from their surroundings. Heat transfer always occurs from high region to lower region. Temperature means temperature. Heat transfer changes the internal energy of both systems involved the thermodynamical enthalpy by measuring heat transfer. The thermal equilibrium is reached when all involved bodies and the surrounding reach the same temperature. The thermal expansion is the tendency of matter to change in the volume in response to change in the temperature. Modes of heat temperature. There are three modes of heat temperature or three processes of heat temperature are conduction, convection and the radiation. Modes of heat transfer. First, Heat can be transferred by three different modes. First is conduction, is the transfer of energy from more energy particle of substance to less energy result interaction between the particle in the solid. It is due to combination of vibration of molecules in lattice and energy transported by free electrons. In the gaseous liquid, conduction is due to collision and diffusion of molecules during their random motion. The rate of heat conduction through the plane layer proportional to temperature difference across the layer. Heat transfer area is inversely proportional to thickness of the layer. The rate of conduction is proportional to area temperature difference upon thickness. That is Q conduction Ka T1 minus T2 upon del x, or it can be written as minus Ka del Tx. K is called the thermal conductivity and dt of dx of a temperature gradient is the slope of the temperature curve on Tx axis. Thermal conductivity K is the property of material. uh, for K diamond it is very high, perfect, since that is high power to laser power diodes. K human is very low. K air is also very low, is good conductor. Used for human insulation, woolen clothing and window double glazing. Convention, the mode of energy transfer between the solid surface and the adjacent liquid of gas is the motion involved. The combination effect is conduction motion. Cold air follows above the hot copper plate. In the absence of any bulk fluid motion, heat transfer between in solid surface and the adjacent fluid is pure conduction, the type of convection. The natural convection and forced convection. Natural conventional, in which fluid motion occurs due to density variation caused by the temperature difference. The forced conventional, fluid motion caused by external agency. Newton law of cooling is given by Q conventional HAX Tx minus T infinity. H is called conventional heat transfer coefficient. X is called surface to which conventional heat transfer takes place. T8 0 is the surface temperature. T infinity is the temperature of fluid instantaneously from the surface. Radiation, the energy emitted by the matter in the form of electromagnetic wave is the result changes in electron configuration atoms molecule. Unlike the convection and the conventional heat by modes, heat transfer is steady. We are interested in thermal radiation, which is form of radiation emitted by body because their temperature. Absorption and the Stephen Boltzmann law is Q emit maximum sigma 8 square to the power 4. It is called Stephen Boltzmann law. Stephen surface, where A is the surface area, Stephen Boltzmann constant is sigma equal 5.67 to 10 to the power minus 8 watt meter square k to the power minus 4. Radiation. The energy is transferred by means of electromagnetic wave can be placed through the vacuum. Electromagnetic wave can propagate through the empty space. The average frequency versus absolute temperature drop is shown in this diagram. Radiation, heat transfer between the body if the surrounding is Ts, then the net power radiated is P sigma epsilon A to the power 4 Ts to the power 4. Assuming dark dry night, Ts equal 3K. Concept of thermal resistance. Radiation heat transfer. Thermal resistance. Q1 F1 A1 sigma T1 की power 4 T2 की power 4 W. F1 is known as U factor including the effect of the orientation initial distance between the surface, or Q equal T1 minus T2 upon 1 FA1 sigma T1 plus T2 T1 का square T2 का square, or given by formula del T upon R. Limitation for the use of thermal resistance concept. The thermal concept can be used only when all the following conditions are satisfied. One dimensional conduction, second is steady state conduction, and third is no internal heat generation. Heat is the form of energy which can be flow from temperature difference between the two regions. There are three modes of heat transfer, namely conduction, conventional, and radiation. The temperature difference is the greater the temperature difference, the higher rate of conduction. Cross-sectional area, thicker material conduct the heat faster than thin ones. Thank you so much.